Hello, good afternoon, and welcome to the sixth edition of the TSDSI Tech Deep Dive Conference. Let me introduce Mr. N. Mohan Ram, Director General TSDSI, and invite him to make the opening remarks. Mr. N. Mohan Ram has more than 30 years of experience in research, technology development, and infrastructure development and operations in the domain of high performance computing, high speed communications, and financial technology. He is currently the Director General of Telecommunication Standards Development Society India, India's Telecom STO. Over to you, sir.
Thank you, Akash. Good afternoon. Welcome everyone to the TTDD 2023 conference. We are happy to have you here from October 3rd to 6th. This is the sixth edition of our conference and it's going to be an exciting one. We have 6 online technical sessions that will dive deep into the world of global standardization activities and leading technology trends. Then on October 6th, we'll come together in New Delhi for a special hybrid session. Our theme for this year is 6G Horizons, Converging Technologies for a Connected Society. We will be discussing important topics like 6G vision and drivers, how we can connect the still unconnected, standardization activities, emerging technologies, resilience aspects, and the security challenge we might face. Our special session will focus on building a sustainable future with 6G in India. It's a chance to think about how technology can make our future brighter and more sustainable. Throughout the conference, we'll showcase the work happening in TSDSI and around the world. We'll talk about research, industry trends, and new ideas that could become standards in future. We are also conducting a dedicated session on the role of TSDSI in global standards ecosystem on the 6th to familiarize the audience with our technical activities and processes. It will showcase the wide range of topics that are being standardized globally. I'm quite certain you will find the areas of your interest here and be motivated to contribute. Please do join us for the TSDSA Awards ceremony on 6th in New Delhi or online to celebrate the TSDSA experts who contributed to standards in the financial year 22-23. This conference isn't just about listening, it's about sharing ideas and finding ways to work together. We hope you have a fantastic time, make new connections, and leave with ideas to make the world a better place with 6G technology. Thank you for being part of TTDD 2023. Let's get started. Over to Akash.
Thank you, sir, for addressing the audience. Now I may hand over to Ms. Shweta, who is the coordinator for this session 1.
Thank you, Akash. Welcome everyone in this session 1, 6G Vision and Drivers. This session is sponsored by Tejas Networks. Now, I want to introduce some hygiene instructions. So, all attendees except the session speakers will be kept on mute, audio and video throughout the session by default. If you have any questions for the speakers, please type them in the Q&A tab. Question to the speakers posted in the chat box will not be entertained. You may interact with fellow attendees live using the chats tab during the session. If you want to enlarge your presentation, please click the expanding arrow icon on the top right of the presenting screen. The tool is configured for SD video, so you may switch to LD in case if you are facing any bandwidth problem. This webinar is being recorded and will be posted to the TSDSI website within the next few days. Attendees may like to visit the exhibit booth of TSDSI in between the sessions to know more about our work. Attendees can use the launch facility for networking. The launch will remain open till the end of the conference. Now, I want to invite Ms. Jackie Mittal as session convener. Sri A.K. Mittal is associated with TSDSI as advisor with a special focus on standardization in wireless and wireline systems and handles standards related activities of TSDSI in 3GPP and ITUR. That's all. Hand over to Sir.
Yeah, thank you, Shweta. Good morning, good afternoon, or good evening, as the case may be, depending upon the part of the world you are in. It's an international attendee conference. Welcome to all the distinguished participants, session co-chairs, keynote speakers, and panelists to the first session of the TTDD 2023 with the title 6G Vision and Drivers. Co-chairs of this session are Mr. Jishnu Arvindakshan and Mr. Subhash Mandal. I would like to briefly introduce them. Our first session co-chair is Mr. Jishnu Arvindakshan. He is the principal architect technology in CTO's office of Tejas Networks India Limited and has 19 years of experience in the field of telecom. In the interest of time, I am not reading out the complete details. They are available on our website. And the other co-chair we have is Mr. Subhash Mandal. He leads the R&D effort for 5G products development at HFCL as a senior vice president. In this role, Subhash works with academia, standards development organizations, and technology partners. The portfolio of products include ORAN-based macro RU, indoor small cell, medium range outdoor small cell, and transport products for interconnecting disaggregated RAN nodes. So over to the co-chairs and Mr. Jishnu for carrying the session forward. Thank you very much.
Thank you, Mittal sir, for the introduction. Good afternoon to all the participants joining from India, and good day to all other participants joining from different part of the world. I'm happy to be co-chairing the first session of the 6th TSDSI Tech Deep Dive 2023, 6G Vision and Drivers, along with my co-chair Subhash. So you may be aware that ITUR WP5D finalized the framework or the vision document for IMT 2030. It's also called as 6G in June 2023. Last week, ITUR Study Group 5 made further minor changes into the document and finalized a revised document, which would be published soon. The framework document initiates usually a whole new generation of communication technology. In this case, IMT 2030 would initiate the 6G communication technologies. And I am very happy to introduce two eminent speakers who are among us, who can provide both the international and Indian perspective of the recent development in ITUR. We will have two keynotes, one from Dr. Xiong Chun and another from Mittal sir. Unfortunately, Mittal sir could not be with us today due to some pressing meeting. So he has requested Abhinav sir to basically present in his place. So after the two keynotes, we will have a short Q&A for 10 minutes. As mentioned by Shweta, please use the Q&A bar to type down your question. And I will read out the question to the appropriate speakers after both the sessions are over. The Q&A will be followed by a panel discussion, which would be headed by my co-chair Subhash, and I will hand it over after the Q&A to him. So let me first introduce my first keynote speaker, Dr. Xiong Jun. Xiong Jun is basically received his PhD degree from EECS at the University of Michigan in 2000. He's currently working as a professor at Korea University, Seoul, Korea. He was also been the Republic of Korea's representative to various ITUR working parties, including Working Party 5D, which finalized the 6G or IMT 2030 framework vision. So over to Xiong Jun. I think he has a video, so can we play his video?
Afternoon. afternoon, ladies and gentlemen. This is Song Juno. I'm a professor at Korea University, and also I'm a representative of Republic of Korea for ITUR meeting. Today I'm going to talk about the 6G vision, and which was discussed in ITUR, and the official name of the ITUR 6G vision is IMT 2030 framework. So before I start my talk, I really appreciate the effort by TSDSI for organizing this nice conference. And it's my great honor to be a keynote speaker for this nice and important conference. And one of my colleagues in Korea, they were chairs of the sub-working group in ITR developing this document. And also I developed the contribution from Korea about the this framework. And since I was there so many years, so I try to give my best to summarize what has been talked about there in ITR and what's going to be the 6G. Okay, so I'm going to talk about the 6G, and IMT 2030 framework is the document that I'm going to talk about today, and that was actually approved by ITUR actually last week. Okay, so first I'm going to talk about the history of ITUR IMT family. Okay, so for those who are familiar with this, is pretty straightforward, but I give you about 1 minute to briefly introduce what's the ITUR and what's IMT, and the quick history about 30 years of mobile communication. So ITUR is the international body. They call it the UN agency, and we're basically talking about the frequency and frequency of allocation and frequency assignment, and also the interference between different administrations, and especially those difficult issues. And also they are talking about they provide some guidance for the mobile communication. So IMT means International Mobile Telecommunication, and the International Mobile Communication Standard has been acknowledged or it's kind of approved, not developed. I can talk about that later, but from 3G. And IMT, International Mobile Telecommunication 2000, as you can see in this figure, right, the table, 2000 advanced, and 2020 and 2030 is ongoing. As you can see in the bottom, that's talk about the final, the specification 8. So you can see that it's about the 10 years of the period for one generation is developed. And we are about here, we are under the first phase of 6G. And this table also show how ITUR, International Telecommunication Union, the radio communication sector, is working on the IMT development. So first, they provide the future technology trend report, and it provides a vision for the new generation. And then that the vision is, as you can see later, it's a very high level description of the new generation of mobile communication technology. And then there will be some details, specification requirement. And finally, after some evaluation, submission and evaluation process, ITUR will acknowledge some technology as the IMT 2000 at this time as a 3G, and IMT advanced for 4G. And quite recently, ITUR has acknowledged the 5G technology. So, as I said before, we are at the first part of the 6G, which is year 2023, and the up to a 2030 details specification of 6G, which is called IMT 2030, will be developed. Here's the plan for the ITUR. So we are about here, and as you can see, there's a WRC 23, which will be held in the later this year, November to December, and also WRC 27. So ITR is mostly working on the frequency related issue, frequency assignment, and some issue of the interference, because the mobile communication is only one of many applications and services where the people can use the frequencies. So we're at the first stage, and then the important thing is we have to finalize the vision, which is called the framework of the IMT 2030. And once we have finished the vision here, then we're going to talk about the technical performance and evaluate how those are evaluated, and something like some detailed specification. Then the de facto standard body, actually the 3GPP, they will develop the nice new 6G technology, and they are expected to submit their technology to ITR, and that's called the technology proposal. And the ITR will evaluate their submission, and the people in ITR will have a consensus on the performance and of the new technology proposed by the 3PP, and the outcome and decision will be made over here, and finally 6G will be published as IMT 2030, which satisfy the requirements set by here and the vision set by here. So it's a long way to go. So we are expecting that the 6G will be finalized in ITR in year 2030. That's why we call it IMT 2030. And we are at here, we just finished what's going to be, on what vision it should provide. So I'm going to talk about that. And then, so this is not just, one day. It's been a long time. We talk about it's in the industry and the academia, and so many places they're talking about 6G. And so what is that? So it was last year, June of last year, there was a report, which was also developed by ITR, is the Future Technology Trend Report. So that's where you can see in this timetable. So before vision, people have studied on the what's going to be the future technology on the 6G. And you can look at this document, and there are 3 parts about the some technology enabler, and also radio interface, and the new radio network. And there are many technologies that are presented in this document. It's not that long. It's about 50 pages document. And the yellow highlight is what I focus on, and what I just want to say some highlights. They can see AI, and they try to integrate the sensing and communication, and the communication and the computing are going to converge. I mean, they're tended to converge. And they also talking about the ultra high accuracy positioning, which is the baseline for the sensing. And also they are talking about the digital twin network and the non-terrestrial network interconnection. So, there are many new technology, and I just want to highlight this yellow for something new compared to the previous one. Okay, so this is a baseline, and then it was June this year, and I just want to give you some vibe in the room. And this is this room. We have some photos after it is finalized. And then we have also the photo at the outside, and this is my badge, and this is the chair who just announced that, okay, the vision, the IMT 2030 vision is finalized, okay? So it's just a smooth process. It looks a smooth process, but it's more than 2 years. We have about 6 meetings, and in there are all a lot of conference calls and a lot of contribution from many administrations, many countries, and it was very difficult to have a consensus because there's no voting for the ITR. They try to talk and talk and talk and talk, and they want to they have to compromise. They have to have they just say the consensus. No, they don't say the unanimous, but they have to agree something. Otherwise, cannot go further. So they spend more than two years to visualize what 6G look like. But anyway, this is not the first time for ITR to set up a new mobile communication generation. It was a 6G already. So they have a vision for 3G, and they have a vision for 4G, and they have a vision for 5G, and now they made a vision for 6G. Okay. Compared to the previous generation, 6G, I think, is kind of unique. First of all, 3GPP, yes, you may have heard about 3GPP many times. So 3G, I just said that, okay, 3GPP will develop and 3GPP will propose, and that will be expected to be acknowledged by the ITUR. So it's just a simple, it looks very simple, but that's not the case with the previous generation. For the 5G, from 5G, that's the case. Before 5G, in the 4G and 3G, there's many proponent. You may have heard about the 3PP2, and also in the LTE, there's also the WiMAX. So IEEE also proposed a new technology for 4G, and also that was acknowledged, but that didn't go well in the market. But anyway, practically, you may know, you may not know some other institution or some some de facto standard body may propose a proposal for the 6G technology, but you never know. But it practically, I think that is a good estimate prediction that the 3GPP is the only proponent. Okay, and 6G is discussed only in ITU for now. So I mean, for everyone, 6G is long way to go, and we're still in the early stage of 5G. It's too early to talk about 6G. Everybody agree on that, and they don't see a specific need. Why do we need a 6G? I mean, there's no clear answer. So it looks quite early for 6G, and even more of that is that the 5G, as you can see before, the vision is the first step to set a new mobile communication standard in ITUR. And the ITUR schedule is governed by the WRC. WRC is every 4 years. So for 5G vision case, it was finished by year 2015, which is 5 years from before being finalized. So we have 7 years before, so they're still vague and still not clear what's going to be 6G look like. I think, but there's one big trend in our industry as of now is AI is a big trend. But how AI affect 6G and that's not clear yet. But it's for sure that there will be something AI in 6G. So other than that, I mean, there's from the scratch, the ITU need to discuss how 6G look like, what vision should 6G provide. Okay. But that work has been finished last June, then I'm going to talk about that. So the vision, the document, and I think that I will provide the document for this one. And actually, you can just Google and download freely about the vision document, or sorry, the IMT 2030 framework document, and it's only 22 pages. It's the PDF file, and they consist of 5 sections, and you can see the introduction. Okay, just they talk about the history and just the 1 pages and some references, and they're talking about the trend. Okay, but it's just a trend. Okay, so the what is going on in the technology and what's going on the user application, and okay, so what about the spectrum? But the real thing, I mean, real meat in this document is these 2 things: usage scenario and capability. So usage scenario is basically saying that the 6G will provide a variety of services, variety of new services. That's the message the section 3 would like to say. Section 4, on the other hand, is capability. IMT 2030 6G will outperform the 5G. It's a very good performance system. Okay, so variety of services, variety of new services, and very good performance. So let's talk about section 3 and section 4. Okay, so there's some text description, but the right-hand side, you can see a big circle. Yes, this is the 6G UCG scenario, ICG scenario by IMT 2030. And the message here is that 6G, the IMT 2030, will provide variety of services. This symbolic figure is not new for ITR. You may have seen this figure quite often. Yes, this figure is about the 5G, IMT 2020. You may heard of the enhanced mobile broadband and machine type communication and ultra reliable and low latency communication. I don't know how many of you have seen this one. This is the UCG scenarios kind of a counterpart in 4G. In 4G, they want to provide a high speed and high mobility. That was the main, vision that 20 years ago people have thought about it. And now we're talking about this one. Okay, so let's talk about this figure. So this is, there's a 6. It's kind of a coincidence that the IMT 2036G has the hexagon, but it's just a coincidence because the 5G has a triangle. So EMBB, MMTC, URLLC, that's the IMT 2025G. And the 6G will have enhanced UCG scenario of already proposed 5G UCG scenario. The EMBB will be immersive communication, and the URLLC will be a hyper-reliable and low latency communication, and MMTC will be a massive communication. Yes, massive machine type, and will be a massive communication. I don't know. It's hard to say it's a better, but anyway, it's a massive communication. And in addition to that, we have integrated sensing and communication. For a long time, we say that okay, so sensing is not the part of the communication. So the communication will be integrated with the sensing capability. And also there's the integrated AI. Yes, I said AI many times, that the AI will be integrated into the communication and ubiquitous connectivity. So in the 6G, the ubiquitous connectivity is the long goal of the mobile communication, not 5G nor 4G. I think it's from 3G, even 2G. People want to have a ubiquitous connectivity. So it try to be achieved. I'm not sure it's 100%, but it'll be a quite should be a development in the ubiquitous connectivity. Also, that ubiquitous connectivity implies some interconnection or the interworking with the non-terrestrial communication, like the satellite or some or high altitude base station or something like that. And also, there's the underlying overarching capability that the 6G, the IMT 2030 should provide. It's sustainable, it's a ubiquitous intelligence, and the security, privacy, and resilience, and the connecting the unconnected. So those 4 main concepts is somehow related to the 6 UCG scenario, but we will develop the 6G, or 6G will be developed with these 4 overarching concepts in mind. Okay, so here's the more details. So what's the immersive communication? The extension of the EMBB. There are some use cases over there. And the hyper reliable and low latency communication, it's a low latency URLLC extension with some better use cases. And massive communication, so that's the MMTC extension, and the more use cases are expected for the usage scenario of the extension. 3 new one, the ubiquitous connectivity. I just said that the bridge the digital divide. We're gonna integrate somehow the AI to the 6G and sensing and communication. So we will have localization or movement tracking that will the 6G infrastructure will help or will improve those capabilities. Okay. And those for overarching aspects, I had mentioned this circle around in the usage scenario. We have some time to figure out how to represent this overarching in the figure. Okay, so I have said that the section 3, which is the most important section of this vision framework document, is to say that 6G will provide variety of new services. So now let's talk about the section 4, which is talking about the capability. Okay, so capability diagram is also circular. It's big circle on here, and that will say that basically the message here is that 6G will will provide better services. Will the performance outperform the previous system? Okay, so something like the you may see a peak data rate and the user experience data rate, some spectral efficiency, and so on. So there's some controversy how to present this one. Also, there's a new capability of coverage and sensing related, AI related. These are the new capability that the IMT 2030 will provide it. They are expected to provide it. And this figure, you may have seen this before. So this is about the 5G capability, and there's a clear distinction from 4G IMT Advanced to IMT 2020, but we try to avoid that in the 6G. So anyway, this is the capabilities that the 6G are supposed to have, which is very nice numbers. And as you can see, there's no number here. There was some controversy because for example, big data rate. So it's as you can see, the range and values given the capability are estimated target for research and investigation of this. So there's some disclaimer, but even if there's a disclaimer, there's some number here that is kind of misunderstood and gives a wrong message to the reader. So they I mean, we agree that we're not going to put any number for this peak data rate and those item. But anyway, so the IMT 2030, the 6G will have this new capability to provide such nice services. And okay, so for these 15 capabilities, I just summarized from peak data rate all the way up to the interoperability. So many items are still at the high level. So the next step of ITR is to specify the number and how those are evaluated to acknowledge the proponent from the 3GPP in the later stage of the 6G standardization. Okay, so this is just the high level at this time. Okay, and this one, actually, this is kind of interesting. I have said that the June of this year, the Vision IMT 2030 framework document was finalized, but that's just the working group level, and the official approval is study group 5, which was held last week. And when I made this presentation material, there was some controversy, which is quite rare. And I have said that I have some concern. And I said that study group 5, which is above the working group level, study group seems difficult and is supposed to be resolved in radio assembly, which is in the November. But this is wrong. This is wrong. And actually, happily, the last week, it was all agreed, and the study group 5 has approved the vision document. So anyway, my expectation about 2 weeks ago were wrong, but there was no problem. And study group 5 approved the Vision IMT 2030 framework document, and everything is official. Okay, what's next? Yeah, WRC is more important. The W23 and 27, then we'll talk about the new IMT frequency. It's quite tough topic. And yeah, so 3GPP will prepare their new system, new technology to be acknowledged as the IMT 2030, and from now on, actually they are already working on that. And the minimum performance requirement, the various methodology, as I said before, those capability and use cases, they're all high level. Okay, so what's the specific number and how they are evaluated? That's going to be a job of the ITU for next 3 to 4 years. Okay, so thank you very much for the listening my talk, and I'll be ready for your question. Thank you.
Thank you, Dr. Shongjon. Can we have the next keynote speaker? Yeah. India has significantly contributed to the IMT 2030 framework vision document, which was discussed by Dr. Shongjong as well. So I would now request Shri Avinash Agarwal sir to basically provide how India contributed to this document and how significantly we look forward for leading the 6G development. So can I just give you an introduction? Can you? Yeah. Thank you, Avinash Agarwal, for coming over here. So Avinash Agarwal is an ITS officer from 1992 batch. Presently, is posted as DDG, Deputy Director General Convergence and Broadcasting at TEC, which is India's standard setting organization. So I would now hand over the mic to Avinash Agarwal, and can we project the slides and bring?
Thank you. Thank you, TSDSI, for giving this opportunity, and thank you, Jishnuji, for the introduction. I hope I am audible. And
Yeah, you are audible, I think.
yeah,
You are projecting the screen?
No, I think someone from TSDSI is projecting it. So while the slides are being shown, I would just like to say that the previous keynote speaker has already elaborated on the 6G framework document that ITUR has prepared, and Jishnuji mentioned that India has given significant contributions while this document was being framed. So I will be talking more from the Indian scenario and the Indian perspective. So I'll be talking somewhat about the Bharat 6G vision and also something about IMT 2030. Next, please. If it could be done in a full screen mode, it will be good. Can you show it in the full screen mode? So this is just a slide about the various releases of 3GPP and how we popularly term them as 5G or 6G. So 3GPP release up to 17 is what we popularly term as 5G. Then release 18 to 19 would be 5G advanced, and 3GPP release 19 and subsequent releases would be more or less towards the 6G, which in the ITU terms will be IMT 2030. Next. So next next slide, please. So next, let us discuss about the scenario in India. Very recently, in India, we have 6G mission. We already have the Bharat 6G alliance, and then we have this Bharat 6G vision document also. This is a very important document, that Bharat 6G vision document, because it gives a very clear vision for India in a 6G driven world. And the aim of all this is to enable India to become a leading global supplier of intellectual property, to develop products and solutions of affordable 6G telecom solutions, to deploy 6G technologies, to act as a powerful force multiplier for India at 2030, and to enable inclusive and significant enhancement in the quality of living experiences of citizens in India and across the world. So, like these are some of the key uh, uh, thoughts behind this vision and mission and the alliance. And if you can see on the top right side of the slide, the vision focuses on affordability, sustainability, and ubiquitous connectivity also. So these are very important aspects, and also is the trustworthiness, which is not mentioned here, but it is also a very key component of the 6G vision of India. And as it mentions that the aim is to design, develop, and deploy 6G network technologies that provide ubiquitous, intelligent, and secure connectivity for high quality living experience for the world. And as we go through the slides, when we come to IMT 2030, I will try to uh, link that how Indian contributions were driven by this vision, and where our views were accepted by the international community and became part of the 6G framework or IMT 2030 framework. So let us just go through the key aspects which have been, the topics have been mentioned here, but I will just try to quickly elaborate on each of those things. Like very first is the tactile internet. So in ITU terms, it is tactile internet is an internet network that combines ultra low latency with extremely high availability, reliability, and security. And it need not be just personal. It need not be just for businesses. It should be for the individuals also. The aim is to provide an infrastructure to enable remote controlled mobile robotic solutions for everyone. So we are not just talking of businesses, but also for individuals. And also this tactile internet will be the next evolution of the Internet of Things, and it would be encompassing human to machine to machine interactions, and it will enable real time interactive systems with many industrial, societal, and business use cases. Another aspect is artificial intelligence on the air interface. So, with the help of artificial intelligence, we can choose many parameters in a radio network in a more efficient manner than a human would do. So, using artificial intelligence, the RAN can adapt its signaling schemes to achieve the best performance for any situation. Another is distributed intelligence in the network. So future 6G networks are expected to deliver quality of experience through integration of communication, computation, and artificial intelligence. So the integration of artificial intelligence in communication networks is expected to utilize both centralized and distributed intelligence in complex applications and deployment scenarios. uh, Tele-operated autonomous driving. So here again, vehicle to anything, integrated radar sensing, communication in 6G, all these can enable tele-operated autonomous driving, which is also going to be a big use case. Then holographic communication along with AR, VR, XR. So this is also being considered as one of the top use cases of 6G, where holographic communication refers to real-time capturing, encoding, transporting, and rendering of 3D representations. The integration of communication, computing, and processing in 6G will improve the quality of experience pursued by the different users, and it will deliver new immersive applications, and it has the possibility of making metaverse a reality. uh, then we have the next gen industries. So that also is going to be a big use case for 6G, like with ultra low latency and high speeds. 6G is expected to enhance machine to machine and human to human interactions, involving use of virtual and augmented reality, mobile edge computing, and other things. Then we have the 6G devices, including the IoT and biological devices. So the 6G ecosystem is expected to harbor a variety of user devices. It could be wearables, it could be embedded devices like body sensors, cameras, trackers, in addition to conventional devices like phones and tablets. So such devices are expected to revolutionize the IoT applications like smart cities, smart agriculture, and also various new applications like digital twins and other things. Then we have the hyper-connected digital world, where we will be having massive number of humans, machines, and things connected in wireless networks to sense, process, act, and communicate with the surrounding environment in a real-time manner. Security and trust that we already know that is a very important aspect. And then we have the integrated terrestrial and non-terrestrial networks. So the 6G framework that the previous keynote speaker mentioned was primarily focused on the terrestrial network, but as we see that for providing ubiquitous connectivity and other things, there is a need for integrating terrestrial and non-terrestrial networks, which includes satellites, like we are seeing popularity of low Earth orbit satellites, and then there are new technologies such as HAPS, which could be part of non-terrestrial wireless networks. And then we also have the drone uses, which is drone communication would be there. So all these things are going to be there, and the Bharat 6G vision emphasizes on these aspects. Let us go to the next slide. So we'll just quickly go through the key recommendations which could enable the Bharat 6G mission, and these include like innovative funding mechanisms to support industry, startups, academia, and national laboratories to undertake research and development and pursue risk pathways in search of breakthroughs. Uh, uh, it also involves innovative solutions through startups that leverage the emerging 6G technologies to address key verticals. Though those could be like verticals of transport, water, power grid, renewables, healthcare, education, digital twins, smart cities, and so on. Then we have these multi-sensor and man-machine interfaces and devices leveraging edge cloud computing resources and AI to deliver textile internet. Uh, we have shared use of spectrum, particularly in the high frequency bands where the propagation is more akin to that of light. Reassessment and rationalization of congested spectrum bands, adoption of captive networks for Industry 4.0 and enterprise use cases. Uh, we also have these millimeter wave and sub-terahertz wireless communications. One of the recommendations is there. Then we have tactile internet and remote operations of machines, robots, along with near realistic 3D rendering of virtual participants in meetings. Uh, Participation and contribution to global standards forums to ensure interoperability and global reach of our innovation. So, like interoperability is one of the capabilities that is there in the 6G framework also, and our vision document also mentions about the same while participating with global standardization forums. Next, please. So these are some of the important trends which are there in the IMT 2030 or 6G application trends, where if we see that there is a focus on ubiquitous intelligence, which means like intelligence, or when we say intelligence, like it is kind of artificial intelligence, which would be present everywhere. Ubiquitous means like it is present everywhere. So we have this intelligence which is present in every part of the communication system and not just in any isolated component of the system. So like we have that ubiquitous intelligence, we have ubiquitous computing, then immersive multimedia and multisensory interactions, digital twin, virtual world, smart industrial applications, digital health and well-being, ubiquitous connectivity, which again like was one of the key areas where India contributed. And by ubiquitous connectivity, the idea is to have to provide connectivity to the unconnected, to bridge the digital divide, so that we are able to access a variety of services anytime, anywhere. So that is ubiquitous connectivity. Integration of sensing and communication, then also sustainability. So here again, sustainability means environmental sustainability. It includes energy efficiency, equipment longevity, and then we have all those 3 R's like repair, reuse, and recycle. Uh, so we have the usage scenario for 6G, which the previous speaker has already covered this thing. So I will elaborate on the aspect where India specifically contributed, and we contributed on other aspects also. But like one of the usage scenarios, ubiquitous connectivity was primarily the suggestion from India, and it is good that the international community uh, understood its requirement, and finally it became part of the ITU recommendation, draft recommendation also. So the other 6 are already there. The 3 are enhancements of the previous usage scenarios of 5G, and 3 are new ones, as the previous keynote speaker has already elaborated. So I will not repeat the same, but I would only say that the ubiquitous connectivity, which relates to bridging the digital divide or connecting the unconnected, is something where we are happy to contribute. Our contributions were accepted. Next, capabilities. Next is again the same capabilities, part of the IMT 23 framework document, which our previous speaker has mentioned. So again, I will not repeat the same, but I would say that if you see the green part, which is the enhanced capability, and the blue part, which has the new capabilities. So in the blue part, if it is readable, you can see the one is coverage, and then towards the right side of blue part, we have sustainability and interoperability. So these 3 are the new capabilities, which were not which were like proposed by India. So coverage, sustainability, and interoperability were 3 inputs that were proposed, or primarily proposed by India, and I think were accepted. And I think there is a big earthquake going on here. I hope the audience can also feel it. So perhaps I will continue. Yeah, it's a big earthquake, it's still going on. So should I continue? These are the enhancements in capabilities. We can see that there is a substantial enhancement. So I think we need to take a break. It's continuing for a very, very long time.
Okay, so if you have to break and first you make yourself safe before we continue. So
Yeah.
do you have to leave?
I think it has stopped now, but it was a very long earthquake. We could feel it very badly here, and people are already out of their chambers, so I think it has stopped. Yeah. So we can see that there is a significant enhancement in the capabilities, and as compared to 5G. So there is a big enhancement, especially if they see the reliability. It is almost 10 to 100 times enhanced. Then connection density again 10 to 100 times enhanced. And latency again almost 10 times enhanced. Mobility almost double. Area traffic capability is 3 to 5 times enhanced. User experience data rate again 3 to 5 times enhanced. Peak data rate 10 times enhanced. So there's a very, very significant improvement anticipated in the capabilities as compared to 5G in 6G. Next, please. Yeah. So this slide gives an idea about spectrum considerations, which will be a big talking point. Then this figure typically shows the 3 dimensions of 6G spectrum, where we have the bandwidth, then we have the frequency and the coverage. So as we can see, the frequency, as we go higher and higher on the higher side of the frequency, the coverage would perhaps the coverage would get reduced. But at the same time, like we have the availability of continuous bandwidth, which is more on the higher side. So we have the low, mid, and then higher, and the very high sub-terahertz frequencies available. Next. This is the timeline, ITU-R timeline for IMT 2030. So we are already like this, if you see on the left side, the second block from the top, we have recommendation of a new framework of IMT 2030 and beyond that is available. But the next two big documents would be technical performance requirements, which we can say as TPR, and we have the evaluation criteria and methodology. So these are the two big documents which would be now required, and they have to be prepared. And here again, I will say that in India, like the contributions to 3GPP are basically led by our TSDSI, and contributions for ITU are routed through the National Study Group, which is in this case National Study Group 5, in which the senior DG TEC is the chair, and the previous contributions were also to this ITU framework were also routed through this NSG 5, and TEC was in the position to lead the contributions, and many of the experts are available in this workshop also. So this is all contribution driven, whether it is 3GPP or ITU are discussions or documents. So again, while the contributions are there, we would require that we have given some contributions and the capabilities or user scenarios have been added. Now we need to further develop on those things and have contributions on an ongoing basis for technical performance requirements and evaluation criteria methodology also. Next, please. Similarly, like this is the timeline for 3GPP for IMT 2030 release, and it is like release 19 is there, and it is scheduled to be completed by 2025. So perhaps these are some of the key aspects that I would like I wanted to touch. Thank you. If there are any questions, I would be happy to answer. Thank you.
Thank you, Shri Avinash ji. So maybe we can take few questions. So if there are any questions, please type it in the Q&A box, and I can read it out. So I don't see any question now. So let me first ask a question to Dr. Shongjun. So if you see you had mentioned that AI is a key trend in 6G. And the main topic of interest of your research as well is AI. In SG5 last week, there were concerns on artificial intelligence, and we had to add a word called provably manageable AI to get it through. And there was also the word integrated got dropped from integrated AI in communication. Do we really need to be concerned about AI in communication?
Thanks very much for your question. So, yeah, for AI, as I said in my presentation, so everybody agreed that AI is a big trend, and then 6G, we have to take into account AI in somehow. And there are two aspects in the AI in the 6G. The first one is AI will help for communication. The second one is communication can help AI implementation. So, for example, for the air interface can be improved. For example, the MIMO beamforming or radio access network, the resource allocation, the communication perspective, we can get a help from the AI algorithm to make the resource more efficiently used. So that's the area where AI can help the communication. Also, but now the other aspect is, can AI, so the communication help the AI? So as you know, there AI, there's a lot of training. So data are transmitted from the data to the learning, and there must be a lot of data transmission because of AI. So the 6G with the improved capability and capacity, then the communication can help to implement AI training or AI implementation. So there are two aspects, and so I think that AI in 6G will take into account both aspects. Okay, I hope I hope answer your question. Thank you.
Yeah, thank you, Dr. Arang. So there is one more question on the security aspect of it. I think we all require networks to be secure, and I think that's become far more important even in 6G. We have that trustworthiness added into that outer circle as a overarching thing. Do you think quantum can help in that, and quantum technologies can help in making networks more secure in 6G?
Okay, so of course, yes. So security become more and more important, and so 6G should be designed more secure. There's no doubt about it. Actually, there was also a security requirement in 5G as well. If you look at the 5G vision document, there's a clearly stating that the 5G should be designed with the security in mind. So that's the practical aspect and how the designer should take into account. But for the ITR perspective, the ITR it has a specific requirement for the evaluation of the proponent technology. So I think it's quite difficult to have some quantifiable measure about the security of the system. So security will be considered, and then there should be some requirement that, okay, the 6G should be designed in a security sense. But that's the fact. But the quantifiable measure, it's very difficult to say in an ITR perspective. Okay, that's my answer.
Yeah, thank you, Dr. Shang. One more linked question: would blockchain help in that in making networks secure?
Yes, of course, of course. Any cutting edge technology related to the security related will help. But yes, definitely. But is there a direct link between the blockchain and 6G? It's hard to say at this time.
Yeah, I think all the technologies are too early to comment right now. So
Sure,
I
sure.
think we are right now at the top level. Thank you, Abhay Sabru, for that question.
Yes.
Is there any other? So yeah, somebody has mentioned that blockchain is latency sensitive. Yeah, so may not be able to use it in all the usage scenario, right?
Mm-hmm.
So,
Sure.
yeah, so thanks for that question. I think I have one question for Avinash sir. It's basically, I think India has done the ensured that ubiquitous connectivity is part of one of the usage scenario, and it involves interworking with terrestrial, fixed, and even broadcasting and NTN. How do TEC or and at an India level plan to coordinate the activities beyond NSG5, beyond the terrestrial component of it?
Yeah, it's a interesting question because NSG5 is primarily related to the terrestrial aspects, but then we have the study group 4, which is for the satellite, and then study group 6 of I'm talking of ITUR. So 6 is for broadcasting. So of course, TEC will be coordinating within the country and also representing in the international bodies, and that's why in this my presentation also I mentioned that we have prepared the framework document, but let us start working on the next part, which is like this TPR and other things. And so let us start right now. And for non-terrestrial network, like within TEC, we are already working on a few things like the interface requirements, other things. So we are uh, looking at all the aspects. And for broadcasting also, that convergence, I think the next session covers some aspects of convergence and ubiquitous connectivity. So definitely TEC is there, and of course the conclusions are coming going to come from experts like you and those who are present here. So I think we all have to move together. But definitely, like we have to think for NTN also, like non-terrestrial networks also, and not just focus only on the terrestrial networks for ubiquitous connectivity.
Yeah, thank you, sir. One more question related to it. I think TTDF is funding 6G research and maybe standardization. How can participants be part of the 6G research funding as well as in the test bed part of subsequent 6G test bed?
So, like, I may not be the right person to answer about TTDF, but surely the funding is available from government and Department of Telecommunication. Perhaps we have to create awareness because we have lots of innovative ideas, lots of people and experts working on various new developments. But sometimes the knowledge of availability of funding is not there. So there, I think we have to, like from the government side, we have to be more visible and perhaps such kinds of events can also provide some information that if they are working in this area, then perhaps there's a possibility of some funding also from the government side. But maybe that I may not be the right person to answer this specific question.
Thank you, sir. Shang Jung, one more question on security. So that seems to be quite interesting for all the participants here. So this question is about AI-enabled sensing and edge computing systems. How can you make what is the strategy for a foolproof 6G system without any mischievous elements, whatever it means? So do you think it would be far more difficult in 6G compared to in 5G with all the edge computing coming in and AI-enabled sensing?
Wow. So the question is kind of a mixing the sensing and the AI. Those two are the new usage scenario. I think, if I understand correctly, the question is about how those two usage scenario are mixed. Well, it's too far, I think, at this time. So that's a good idea. Let's leave it for 7G.
Yeah, I think all of this just we finalized last week, so many of these are yet to sink in for all of us also, right?
Yes.
But yeah, as mentioned by Dr. Xiangjong, like security is a big issue as it was in 5G, even in 6G, it will continue to be a big issue. And now with all the AI-enabled sensing, etc., coming in, yes, all this would be welcome contribution both at ITU and 3GPP to basically fix up all those whatever remote security issues can happen. All of us are like committed to make both 5G, 6G network fully secure, and whatever it needs to be done, like we request all the participants who are there in this call also to come and join us in standardization, so that all these issues can be addressed in a bigger way in both ITU and 3GPP.
Yes.
Any other questions? Shweta, is there any other thing? Can we close the Q&A session and move to the next one? Okay, thanks, Asif. So I think thank you, Dr. Xiangjong and Avinash, for giving this talk. It was quite a wonderful talk from both of you. Thank you again. And maybe now can I request Subhash to take over and do the panel session?
Yeah, thank you, Jishnu. And thank you, TSDSI, for having me here. So, Shweta, may I request you to put on the bio of the panel? So, as you see, that 6G is really disruptive, and I will take the tremor in Delhi as a good omen to show that 6G is really going to disrupt the technology landscape, and India is going to have a significant role to play in that. So with that note, I would like to introduce 4 exciting and experienced industry veterans as my panel speakers. So on this topic of the 6G vision and drivers, in this panel, we are going to look at how the 6G is really enabling a set of new use cases. And with this set of panel members telling us through their stories in their segment of org, how that is going to impact. So with that, we have the first speaker, panel speaker, Dibya Mohan. She works for Flipkart Labs as an engineering head, and they are doing innovation with moonshot projects in the areas of Web3, 3D, AR, generative AI, and Flipverse is one of the babies that they have created. So that is about Shweta. Let's move to the next speaker. We next have Prashanto. Prashanto comes with a very rich experience over 30 years. He is currently the head of Applied Analytics and Intelligence, Advanced Engineering Department, Engineering Research Center, and Tata Motors. And to his credit, he also has the control of the Nano car. If you have heard about it, Nano car created the sensation with the cost-effective solution. Some of the previous speakers talked about the need for cost effectiveness. Probably some dimension will get from that. The next speaker is Ravi Prasad. He is a technology leader with deep expertise across immersive technology, generative AI, integration platform, cloud, cognitive content automation, and digital experience platform. Incubated new technology practices and experience centers drove user adoption. So he is working in the metaverse, and that's an area probably going to challenge the network capabilities, and hopefully 6G is going to be an answer to that. So next we move to Vinith. Vinith comes with a different industry background in the medical domain. He is an IT professional with over 22 years of experience and serving GE Healthcare for more than 13 years, now as a senior staff IT infrastructure, architecture, and consultant. So these are the panel speakers that we have. So we already heard a lot about what 6G vision is going to look like, what India's vision is going to be, Bharat 6G vision. Both Dr. Shangjun and Mr. Avinash Agarwal talked about it. So what I am going to do, I will just present one slide view from some of the talk that has already happened to set the context, and then I'll follow up with a set of panel questions to explore the topic further. So Shweta, if you allow me to share my screen, I just would present one slide. All right, so this slide has already been talked about, so I wouldn't take too much of time. So as you see, the 5G was a triangle from the use case scenarios, and this panel is going to explore about the use case scenarios. What has already gone in ITU? Does that meet all the requirement that we are looking from India? Or is there something else that needs to be added that potentially could areas to be explored further at the technical capabilities section that Shangjun and Mr. Avinash already has talked about. So as you see that there are 6 user scenarios in 6G, so that pretty much befitting with the nomenclature of IMT 2030 addressing the 6G network. It is becoming 6 use case scenarios instead of 3 that we had. And as you see that the ITU framework has already talked about the EMBB, MMTC, and URLLC extending a bit to get to fit its vertex into the, I would say, the hexagon of the use cases that is coming in. And the 3 new cases has already been talked about. So you see the EMBB is becoming immersive communications. So our panel, we are going to look at what are some of these immersive communication aspects. Is there something that 5G is falling short of? What additionally needs to be brought in? We'll examine a little bit through the discussion in the panel. Then massive machine type communication is not machine type anymore. It is becoming a massive communication. Ultra reliable low latency is becoming hyper reliable low latency. Now, has been talked about ubiquitous connectivity. There has been talks about convergence of technologies, terrestrial, non-terrestrial, probably in an pursuit of bringing in ubiquitous connectivity, integrated AI and communication. The excitement as well as concerns both are surfacing as we had from the previous conversation, and integrated sensing and communication. And across all of them, there are four overarching aspects from the design principles point of view: sustainability, ubiquitous connectivity, ubiquitous intelligence, security, privacy, and resilience. So with that in context, what I would do is I'll go over the panel members and request them, each one of them, to share their views on these use cases. So I'll keep the screen for a while, and I probably would request Divya to begin with. Divya, would you like to share your views on these use cases? Is that something that is already addressing all your need, or is there anything else that you think should be considered? So if you could come on camera and share your views, that would be great.
Hey, Subhash. Thank you so much. Am I audible?
Yes, you are.
Hey, thanks so much, Subhash. So let me, since we have global audience, I'll probably take 2 minutes of introduction to tell what is Flipkart probably that gives and perspective on what kind of problem statements that we are trying to solve, and then probably talk about the challenges. Flipkart is an Indian e-commerce company that was started about 15, 16 years back, and the objective was how to bring in this online shopping experience to every nook and corner of India. That was the vision with which Flipkart started. And over the years, there were a lot of innovation technologies like cash on delivery, buy now, pay later, a lot of innovation things that happened on the e-commerce space that came up from Flipkart. And continuing the same trend, there has been a constant need and necessity on how we think that technology can change and bring in that value add to the Indian consumers, right? And that is where our adaptation of Web3 comes in, right? Where we started last year with Flipkart Labs. Flipkart Labs is a moonshot factory. What it means is that I hear that there is some noise. Is it okay now, or
Yeah, it is okay now.
Yeah, you are okay.
Sure. So we started with the vision that how could we use Web3 technologies and bring that innovation and disrupt the Indian market, right? At the same time, creating value for Indian consumers and disrupting the consumer space. With that, last year, Firedrops, which is a Flipkart's Web3 platform, was launched, right? And last year, it was more like concept testing for us to understand what works for Indian user. So the first thing that we launched was a partnership with Nothing Phone. Nothing Phone was coming up with their global first version of launch of their phone, where we partnered, and we were the platform for their NFT. So with every phone, and user would get an NFT, and which had a utility for it, right? And we partnered, and globally about 66% of NFT that got minted for nothing was from the Firedrops platform, which was our Indian platform. That was our first thing. And what we learned from that is utility is always very important for the consumer. Second thing, what we did is also a lot of quest around our biggest sale of the year, which is called Big Billion Day, which happens around October. So it is right around the corner this year also. You have huge discounts. It's a value proposition that every Indian user looks for, right? Because of the amount of discounts they get. So we brought in a concept of quest, right? And what quest told us is that it is always about engagement user. It is not no more about transaction, right? It is not just go see something, buy something, right? Engagement is very important for the user. And then third pilot that we did was during our Diwali, where we launched the metaverse experience. We called it Flipverse, where a user would travel through space and land into this spacecraft. So because he's traveled through space, he's in a general neutral avatar, and he could go out there to an incubation center and claim his avatar or a digital twin, and then go around different shopping experiences which were created, like a 3D models and shopping experience that was created. And we also added utility with whoever minted an NFT would have extra discounts and benefits. So what we learned from that is a user spent about 6x more time on an immersive experience compared to a normal shopping user experience, right? So what it said is, user always looks for immersive experience. More the immersive experience, the more engagement and more involvement of the user. Coming back to the question, with this context in mind and what we are trying to solve for Indian consumers, Subhash asked me what are the challenges. So I'll give two perspectives, right? When we launched Flippers, what was the challenge we faced, and probably also give a little general as an industry what is the challenge that is facing. When we launched Flippers, what we wanted is metaverse is that space where it is interconnected, interoperable space, right? Which means that multiple simultaneous connection is needed. But what we were launching is an user experience on a mobile, so you have it on your palm and you look at it, which means that it has to be over using your mobile data. It cannot consume a lot of data, but experience has to be immersive, not compromised. At the same time, how do you create that value add, right? So we had to make choices on how do we do it, because you can't really download everything on user mobile, because you would have consumed literally all the data. Resources are of really limited size when you're doing it on the mobile. So how do we do this? What we did is we had a server running on the cloud, and we pixel stream per user. What it also meant that for every user we had to spawn one instance, one hardware instance dedicated. We could have simultaneous connection, but we couldn't have simultaneous connection talking to each other. What it means that in the space, only user who is navigating through is doing the real time experience, but you couldn't get another person doing a real time because of the challenges of hardware plus the bandwidth, right? That was the biggest thing. And also, how do you give this user experience just through mobile? How do you make them navigate through that space? How do you move? How do you turn? How do you even choose certain things, right? So we had to really do a lot of trial and error to bring in these aspects, which means that latency, speed, hardware, all these were the constraints with which we had to operate. And we made sure that we did something with whatever available, right? With a question Subhash asked me, for 6G, what is that you're looking at? What it means for the space is, right, it is simultaneous connection. And what it also means is, in the world for now, there are about 4.1 billion mobile users, smartphone users, and there are about 13.3 or 13.4 billion IoT devices that is connected, right? But when we are talking about metaverse, it is a space that you yourself are present, the people around you are present, and also these devices, which is your surrounding, it is your objects in the surrounding, which all becomes the 3D models in that space. It means that the data that you are going to see is something that is unimaginable still now. We don't understand that kind of data. Of course, we have been talking about big data, we have been talking about data from AI, but this data is going to be even more huge and unimaginable, right? That is where a network, which is just not means of communication, but it has to be low latent, and everything that the speakers were talking about, right, the keynote speakers were talking about, becomes very important. Seamless communication. How do you even, when you say immersive is just not about seeing, right? Because it goes into the extended reality form. It's just not about seeing, it is feeling, it is sensing it. So how can you bring the sense, the choice of smell, taste, research going on, all these aspects, haptic suits, etc.? How do you bring in, collaborate all of these and bring into that network, right? I think that is the current biggest challenge that you're facing. But to start off with, I think the latency, the hardware, all of these needs to evolve, and at every layer it needs to evolve. It's just not network, hardware, even your UX needs to evolve to make this happen.
Thank you, Divya. I think that was very, very well articulated. So, from consumer perspective, it's all about immersive experience and how 6G could bring in the integrated, ubiquitous access in such a fashion that it can give the right amount of bandwidth at a low latency that the application requires, and also the hardware computing capabilities that could be offloaded from the devices so that any service could be enabled in an affordable manner to the end user, be it the latest smartphone user versus not so smartphone user. You are expecting that the experience could be delivered across different device types in a cost effective manner. Thank you, Divya. That was very helpful. I next would request Ravi. Ravi, if you would like to give your perspectives on the use cases and what you are seeing from the areas of work that you have been doing.
Thank you, Subhas. I'm audible.
You are.
Yeah. Yeah, I think relating to the use cases, what you just walked out, Subhas, if you think about metaverse world, right? See, a couple of examples I'm dealing with in Wipro, right? Especially in the sports and media entertainment industry, right? We're working with a fan engagement use case, right? It's more of how can we make the experience real in a virtual world, especially in like a theater setup or a stadium setup, right? Where you want to invite a global audience and still connect it and still make it real, right? That is a challenge we face, right? Because beyond the enablement technologies, right? One is ubiquitous connectivity, what you just mentioned makes absolutely point on. High bandwidth connectivity is required, low latency network is required. More and beyond this, all this experience has to be persistent across a global audience, right? And if we talk about millions of fans I'm going to invite in a virtual world, you can think about the amount of bandwidth that is required, and everything has to be rendered in real time. Streaming has to happen real time, right? So the challenges what we face typically is any types of 3D assets, especially in the virtual world context, right, where it runs to gigabytes of storage memories, right? How can we make render those types? Example, in a football stadium, right? If I want to deliver the stadium setup itself and render across a global footprint in terms of rendering, streaming, I don't think if this connectivity is not there, 5G is there, still I see there is a lot of evolution has to happen in that space, because as I speak, when I'm just at this point of time, we are cherry picking some use cases for the customers and we're going back and delivering the experience. But when it comes to scale, right, and that is where we fall short because of the need of this connectivity, right? So as I speak, things are evolving. I think some of the use cases what you have listed down in the 5G as well as 6G vision is spot on, especially immersive communication, right? It is really required there. And I see also in the vision of 5G, like in terms of AR, VR, extended reality, and virtual worlds, digital twins, and all, right? It's all part of the larger vision, right? So I'm also looking forward to the evolution and more maturity in 5G adoption framework. Today, as I speak, most of my interactions with enterprise customers, this is the only the broader challenge which I'm seeing. They're saying, yes, these are all fine. What it means in terms of me scaling up to their expectations, right? You're coming back and showing this experience, because I'm talking about rendering the interactions from head-mounted devices to the real devices on the ground, physical devices on the ground, and still ensuring that the content and the streaming happens in real time, right? I don't think if you don't have this high band connectivity, latency in place, I don't think we'll be able to deliver this immersive experience, because the expectation is 5G takes about less than 20 milliseconds, right? And I believe 6G is talking about 100 times the latency improvement, right? And it's a phenomenal thing if you ask me, if it's going to become real. And that is a point of time, if you ask me, metaverse is going to become a reality. Because otherwise, today as I speak, we're all experimenting use cases. And right now, the type of use cases which I'm dealing with are all of visualization use cases. Example, marketing campaigns or a new product rollouts. We're creating the virtual stores for them and creating the visualizations of the assets, right? And that's one side. Immersive learning, right? That's another area which is gaining tractions. In the same context, even from the AI avatars, right? What you're talking about, digital twins of a physical person. Now, I think I saw that also in the vision, that holographic communication, right? And that is going to evolve now, because the need of a face attached to a interaction, right? Today, whatever the AI you apply to the avatar, you can't still make it engaging and interactive. So only way is you can take a physical copy of your camera shootout of your own face and start rendering in a broader global audience, that holographic images I'm talking about. And that again calls for your network bandwidth, connectivity, low latency work. So if you ask me all the use cases what you have mentioned, I would be really looking forward to the evolution of this maturity of these 5G use cases, right? And that's a challenge if you ask me, Subhash, on the ground. This is just my experience about how are we evolving as I speak. B2B segment is growing fine because at least they have the network infrastructure in place, they have investment plan in place. But from a consumer standpoint, right, and that is where an enterprise come back to me saying that, yes, fine, how can I scale up my infrastructure to meet your immersive experience, right? So to me, if you ask me, first largest challenge which I have on the ground is network infrastructure. So I think this 5G spot on. And if you look at the statistics of India, last year when the 5G was rolled out, I think our Honorable Prime Minister Narendra Modi announced that one in October last year. I remember that one, right? And now if you look at the way we have scaled up India, it is the fastest in the world. I think as I understand now, I was reading through some data, right? Around 3 million sites are now 5G enabled, right? That's a huge hats off to Narendra Modi for driving this one, and India should be very proud of this one because not all countries in the world are able to scale up to this extent of maturity. So I see very positive note for the 5G evolution in India as well as the globe, and also I presume the 6G also will come down the lane. So that's a brief experience I want to share across Subhash.
Yeah, thanks, Ravi. Just to summarize what you said, I think making the experience real, making it scale, real-time rendering, and how do you really address the development of the consumer segment and enable the enterprises to allow the enterprises to render the consumer experience that will really differentiate what it takes, right?
Definitely.
That's essentially the summary of what you said. So it is echoing with what Dibya talked about. Thank you, Ravi. We now would move into Prashanta. So Prashanta, you have been working into automotive sector, and you also have been involved into some of the experimentation with the 5G. So maybe you would like to share your views on 6G use cases that has been documented, and is there anything else that you think is going to help accelerate the capabilities beyond what 5G already offers? Prashanta, you have to unmute yourself. Shweta, looks like Prashanta is having a difficulty unmuting himself. Could you help? Am I audible?
You are audible. We will just connect with Mr. Prashanta and see what is the difficulty.
Okay. So meanwhile, maybe what I'll do is I'll go to Vinith. Vinith is working in the medical sector. So Vinith, maybe why don't you share your perspectives on these use cases and some of the challenges? You also have your own private 5G network, so you probably will have a lot to share. So over to you, Vinith.
Hi, thanks for the opportunity. So let me start this story of moving to 6G with what we have on ground right now and what was the proposal from 5G. Okay, so as you see the graph, basically the diagram that you have shared with me, the one in the center is pretty much the 5G piece, right? So that how much of that has been delivered on ground? Okay, that is the first question that I would like to ask. And based on that, we can actually build out solutions and plug in existing solutions into that particular ecosystem. Okay, so if you look at the Bharat 5G vision or 6G vision, especially the task force basically who actually worked behind it in Section 7, I think the two key aspects that they've been discussing is one is the mobility piece and the other one is the inclusiveness of it. And I truly go for that, basically because the impact of 5G is pretty much has been onto the service sector, the service provider sector, basically the infrastructure piece of it. Okay, so that is pretty much the backbone of the the networking aspects that we actually require to achieve that. Okay, and 5G is spot on that piece. But when it comes to the actual user equipment piece and how the user actually uses that part of it, there are still, I sadly have to say that there are still people who thinks that connecting a 5G dongle to an existing compute infrastructure will make it 5G ready. Okay, so that's the definition of 5G itself is something which I think we have to bring to the end customer a little bit more more with more clarity basically on that space. So there are a lot of functionalities that in 5G that we actually have to turn up in the user equipments, so that actually we can actually make use of the complete potential of 5G. Okay, so that knowledge is something actually we have to bring it into the current space and make sure that the user equipment ecosystem is something is ready to actually go to the next level, like 6G, for example, for more inclusiveness and more mobility and more security and things like that. Okay, so that's the first part I would like to, a platform that I would like to place. And I think we have to make sure that our basement is rock solid and have all these key elements in place, and then we move into the next 6G vision kind of things. Okay, so maybe that's a long shot, but I think we are rightly moving in that direction with that pace. Now coming back to where GE Healthcare is looking forward to in that area. GE, as you know, is more, our approach is more patient-centric. So the patient, the end user who is actually going to get the benefit out of all these solutions that we are providing, the healthcare solutions that we are providing, is going to be the key, the customer piece here. Okay, so what can make the life of a patient more inclusive, more relaxing, and more better way of during the tough times. How can we actually have more better interaction with the patient is something which is very key to GHC. Okay, so looking at that perspective, especially what we have, but all the rest of the audience and the rest of the panel has actually mentioned, the immersive experience is comes into picture there as well. Okay, so when you look at in a normal routine of a patient coming to an outpatient department of a hospital or to meet a doctor in the nearby clinic, the first thing which he or she will go through is a set of undergoing the diagnosis of his or her vitals, basically like the BP, temperature, and so on and so forth. So using the the gadgetries that we have nowadays, pretty much all those things can be actually being pre-monitored. As soon as the patient arrives, pretty much all these data is already there with them. Okay, right? All the gadgetries are there in the market right nowadays, and this data is simply can be fetched into, and we can avoid that time delay that the patient feels to get the vitals checked before getting into the patient. So looking at each of these very small use cases, can start with those very small entities which you actually eliminate from the workflow using 6G technology. Okay, and can make a significant improvement in the way that patient feels. Because what she feels is to reach a doctor as soon as possible and convey her issues or his or her issues with the doctor, right? So that time delay because of this vitals check and all those things can be actually be eliminated. Okay, and also when you look at the more advanced way of using 5G and 6G pieces, one of the key aspects that we are looking forward to is the remote connectivity piece and the remote patient diagnostics. And one of the keyword that comes in that part is the digital twin part, basically, that we are looking forward to. So in the current scenario of the digital twins, and G has been in that space for a long time. So right now, the amount of data and the type of data that we acquire from the source is actually something which is very, very specific for a particular purpose. Okay, now when it comes to 6G, the type of data, the amount of data, and the entropy of that data, the disorderedness of that data can all be very high. And there are factors like compute devices, like edge compute devices that will be there on the premise to actually semi-cook that particular data before actually it reaches G, right? So we're looking at all these possibilities, creating a patient jacket, basically, that we call basically after collaborating all this data. Okay, what we call as the patient jacket. Okay, that thing, and making kind of a predictive prognosis, like how the the patient feels and the patient goes on through the lifespan of medication. Okay, and the improvement of that part is concerned. It's going to be the more immersive and more inclusive that part can be, the more better that we can actually provide the treatment, right? Now, it can be a macro level kind of an approach where a patient who comes to doctor like every week or every month or every 2 weeks or something, the frequency is very high. The remote way of doing connectivity with the doctor will always help. And also, in that case, the amount of data that gets transferred from that patient to the doctor, okay, the amount of data will be much higher when compared to just one or two vitals being diagnosed here and there. So the more the data, the more precise will be the diagnosis. So hence, in the end of the day, it not only helps the patient to actually communicate better with the doctor and provide a better prognosis piece in the long run for all the multiple times that he or she visits the doctor, but also doctor will be able to give him or her the precise way of treatment. Okay, so that he or she can recover it from in a much earlier date. That's one part of it. And the other is when you're looking at treatments or procedures in medical procedures, for example. Like for example, the robotic surgery is something which is still in its initial cradle phases in most of the regions. But still, if you look at the remote way of doing that, there are a lot of aspects that come into play. One is definitely the low latency aspect that we have to look at it. It's a URLCC kind of workload basically. So it has to be very low latency kind of communication that needs to happen. Now, when it comes to 6G, there are few more aspects that we can actually bring it into that space. For example, the tactile way of doing things. For example, if you are making an incision on a patient, okay, or a stitch on a patient, the pressure that is felt on the robotic arm can be transmitted all the way down to the tactic glove that the doctor or surgeon wears, right? So that will actually improve the feeling of of that particular procedure to be very precise. Okay, so such technology at a very nano level of data that is getting transmitted from the source to the target, that helps a lot basically. So it's all boils down to immersive experience. In this case, the immersive experience of a surgeon basically. Okay, so so if you look at the overall patient care, be it the latest in tech kind of robotic surgery or something like that, or even the minutest elements like diagnosing the vitals of a patient coming to a hospital, the entire end-to-end areas, there are a lot of things of improvement that can actually be made by actually having more inclusive way of handling the patient data.
Thank you, Vinit. I think to summarize what you just said, how do you do the end-to-end patient life cycle management in a better way is essential expectation. There are two important points that you brought in. I'll just little bit summarize that. One thing that you talked about is the how do you really make 5G really 5G? How do you make 6G really 6G? So you talked about a case where a device which is connected with a 5G dongle, it doesn't make a 5G devices, right? So if I just double click on that a bit, essentially you are looking at rendering a 5G enabled value in the form of the three capabilities in terms of low latency, in terms of massive throughput, and also the ultra reliability, so that the end user can really enhance the experience in the way. So while 5G has enabled a mechanism to expose the network capabilities through network exposure function with a common set of APIs, but are the applications really integrated into it, or
Yes,
it is still two different islands? Is there an opportunity for 6G to really look at it and then make sure that it actually happens in the 6G time frame, right? I think that is one of the area that you talked about. And I think for the awareness of our audience, since this was not probably adequately addressed into the standards, GSMA took up a project called Camara project, where they actually tried to come up with a set of common requirements for integrating the application with the network layer. Would that be integrated part of the 6G would be an interesting question to ask. The second aspect I picked up from your aspect is that if you build a private network and try to cater to your end customer requirements through edge computing and stuff like that, there still are scope in terms of the rendering aspect. Ravi also talked about it, to make sure that end user experience is enhanced. But at the same time, across the device ecosystem, how do you really make this affordable and sustainable becomes a very, very critical aspect, because in your medical segment, you have different strata from the economic affordability point of view, and you would not like to differentiate between a higher economic class versus lower as far as the experience is concerned, right? How do you achieve it? Vinit, thank you very much. I think it gives the perspective and new challenges for 6G to handle. So with that, I would try with Prashanta. Prashanta, hope you are able to come on the floor and share your perspective, Prashanta.
Yeah, am I audible now?
You are, you are.
Yeah. So,
oops, Prashanta seems to having a glitch on the connectivity.
So I'll tell about the problem we face. Okay. So the problem we face is that say different types of customer I have to cater. One is that, for example, a very luxury car. Say another is that low cost vehicles. Say one is that Hexa or that type of big luxury car, or Avinya, which is coming up, and the another is the Ace electric vehicle. So if you see the Ace electric vehicle, it doesn't have the infotainment at all, and whereas the big cars are having good, very big, good quality infotainment and luxury. So the problem here, what we face, or the bus, for example, very expensive, very expensive buses, and it can normally they are able to afford the data cost. But if I work for the common man, and as a forum, we should do this as a TSDSI forum. So we feel that how to and there lies the challenge. So for example, now 6G is here as you, and then how do I cater to the Ace driver who earns some rupees at the end of the day, and then if I want to ask him that you pay me further to monitor your vehicle battery condition, or monitor or motor condition, or the health of those, I think it is not a very good suggestion from that technical or engineers like us. So then what is the middle path? And I'll give a little brief of that, how we are doing it today. So today, we are having the battery digital twin, as many of us were told about the battery digital twin. But when we go to the practical side, it is very expensive. Say there are around 700 cells, and even if I send 30 seconds the voltage and the current and the temperature sensor in the battery pack, it is becoming, and over the year it is not directly contributing to the customer, but it is becoming a data cost is becoming high. So and this is a practical problem. So like you see the customers, the range, and then where the engineers come into, like engineers like us, and how we can help the business as well as the cost. So okay, so now that is a one thing 6G we have to see. So overcome these challenges, even in 5G also, some people are talking about the edge computing. And when recently that last week that TSDSI Spain sorry, not TSDSI, that so some forum, automotive forum was there in that Spain last week, and there also it is that. But how do we code the edge devices? For example, as everybody knows that when we started the C coding very early days, so that ANSI was the standard, but it was not a very good and robust standard compared to which is required for the safety setup. Then the MISRA came. Similarly, for the aerospace safety, some DO 170, somebody like Mathos came. The same way, if we are able to formulate some standard where we can we can develop the edge devices in a safe and secure fashion, then we can process. Say somebody also told that semi-cooked food, so we can process a lot of data at the edge and send the semi-processed or half modeled data to the server. That way we can reduce the cost of the entire digital twin, and we can serve it better way for the customers like Ace, as well as it will reduce the cost of the data transport cost of the buses, as well as the big vehicles like Hexa or Safari for that. So that is what the standardization of the edge devices is one of the way forward. Like I request the 6G forum also to see into it so that we can do it. And that's all my submission to the forum. And as a overall, maybe we can do it in India. Maybe like last time 5G, we wanted to do a ambulance project. The same way, we have done it in privately. So now, not under TSDSI heading. So now this time, I'll request that myself, would like to do that type of project under TSDSI forum with all support from all other people, and on the 6G fashion.
Thank
so
you,
that we can move it earlier before the standards roll out. Thank you. That's all.
Yeah. Thank you, Prashanta. I think if I hear you right, you are talking about the digital divide. How do you really bridge that? You can offer the same set of services to your luxury customer segment, as well as those marginal customers like the drivers who have been earning few rupees for their livelihood. How the edge computing could enable the federation of the intelligence in different layers of the network, so that it becomes the first stage probably does a pre-processing rather than fully cooking the recipe, hands over to the next layer, so that the distributed intelligence enables the ubiquitous computing, ubiquitous connectivity, and same grade of services, of course, with a different quality, to make sure that the provider also is able to sustain the business in a business viable way. That's the summary of what I talked about, and you are very interested in contributing into the edge computing, edge intelligence evolution in the 6G time frame, so that it becomes more inclusive. Thank you, Prashanta. I think that's a very well round of thought. And since we are very tight on the time, what I will do is I will just wrap up this with just one follow-up question to each of you. So you have seen the global use cases that ITU has envisioned. Of course, India has given its inputs. Ubiquitous connectivity has become one of the vertex of the hexagon, and India has significantly contributed in that. But you, as the set of industry veterans who are very close to the customer into different segments, and you have shared some of your experience, is there just one thing that you would like to say that is not probably addressed or should be taken up for the technology development part from the usage case point of view? So I will go over each one of you each one of you take just 15 seconds and tell just one scenario that you think is very, very critical for you. So I go in the reverse order, probably Prashanta, you are the last. Why don't you get started and finish off with your just one input that is going to help the 6G requirement.
Okay, 6G requirement, maybe the like one of the challenge what we are facing need to be overcome is by, say, either commonization of compression technique or like how to reduce the data cost. That is what my demand from the business. We have to enable. We have to see that.
Great, thank you. So reducing data cost is your number one priority. Maybe Vinith, just one sentence overview.
Yeah. So G is always patient-centric. So I would like to give more emphasis to the inclusiveness of that. You know, how 5G has been addressing the telco world a lot now, but there should be somebody speaking at the UE level. Okay. In the end of the day, and so give more focus onto the UE level, increase the how to increase the inclusiveness of the various ways in which we interact using UEs. That and one area, and then obviously the cybersec aspects. Rather than simply saying cybersec, I think we can propose more terminologies and technologies, in that areas to exactly how to do that piece.
Okay, thank you, Vinith. So inclusive end user experience in a secure manner is your take. Thank you.
Precisely.
All right. So then I move into Ravi.
I think for me, if you ask me, automated or maybe intelligent automated provisioning of network slices at the edge locations, right? Because when you're talking about 6G and you're talking about its performance and all, but it also boils down to the point about how are you going to provisioning that in the real time at the edge locations. Probably that's one area which I thought probably would help us.
Okay. Thank you, Ravi. So intelligence at the edge to enable automated provisioning of the network in such a fashion that the end users can achieve the goal, and the enterprises can use that as a tool to provision the network and precisely segment the network to meet the end user requirement in a sustainable and affordable manner.
Yes,
Thank you, Ravi. And Divya, one last word from you.
Hey, Shubhat. For me, I would say, bringing immersive experience to every device possible, right? Every edge device, end user device, I would say, not the edge end user device, right? Which also means supporting interoperability and interconnection of this. So huge amount of data transfer, and also having low end devices supporting this network speed.
Right. Okay. So to summarize, immersive experience everywhere, interconnecting the different clouds like a Flip versus One Universe. Maybe there would be multiple metaverses. How do you interconnect, exchange the data? But for end user, render the experiences seamlessly.
Yeah.
So in essence, you are talking about coming together of network and computing, something that Shangjan talked about at the beginning, in a more inclusive way, bringing the application as integral part of the network fabric, bringing computing as the integral part of the computing fabric and the connectivity fabric. And like Shangjan talked about, AI helping network helping AI. How do you enable that so that there is a federated distributed intelligence across the connectivity fabric? And that makes the connectivity ubiquitous, that makes the intelligence ubiquitous, that makes the ecosystem sustainable, and we can live into a carbon neutral world. So thank you very much for all your perspectives. So we will conclude the panel discussion here. Thank you very much, and I would open the session for question and answer. So Shweta, are there some questions you would like to take up? Okay, so I see some questions in the chat box. One is that tokenization and sharding of patient data is important. etc., so that their data is safe and secure and not misused. So I'm not sure what the question was, but then I guess if it is related to that, I guess it is Vinith who could probably take a cue from this, though the question is not very clear. But you want to make any comment? Tokenization and sharding of patient data?
Yeah, so that part, we call it as anonymization. That part, patient anonymization, that part is something which is already taken care of from day one. Okay,
Got
it's
it.
not 5G or 6G, but any G for that matter. If patient data goes out of the premise, it has to be cleaned. Okay, no patient data needs to be exposed at any cost. So that's kind of some of the key aspects of patient data handling. So that is definitely there. And one edge that I would like to add here with 6Gs and 5Gs is basically the involvement of the edge computing piece in doing that. So the because of compliance reasons, the data could not even leave the premise to cloud or something to even do the cleaning up. Okay, so something has to be done on premise. So the edge computing factors and on-premise computing plays a lot of help there.
Right. Thanks, Vinith. I think I'll move into the next question. That's a very interesting one. You are just discussing use case scenarios. Can you show something real that will actually help us in work? So I think this question is from Ashish. So I will take this. So Ashish, we are talking about 6G, and both Mr. Avinash and Shangjon talked about 6G. Still, we are smoking about it. So far, ITU has defined the framework document that talks about the use cases, that talks about the technology candidates that could potentially be developed by standardization bodies like 3GPP, TSDSI being an integral part of 3GPP ecosystem as one of the SDOs. So it has to develop. So what we are exploring is what are the problems that we would like to solve, rather than creating a technology and saying that, hey, by the way, I have a technology. Is there a problem that I can solve, right? So I think one of the key questions that also is coming up, what is the benefit that 5G is delivering? So if you really look at this becoming monetization of the 5G, question mark is arising. So the question that we are trying to understand is there a use case that is valuable, that the business users, the providers, they can benefit from those values that they can render to the end customers, and therefore create value which is paid by the end consumers, which in turn make the network rollout possible. Because if they are not able to run the business profitably, there is no reason for the network providers to upgrade the infrastructure to say that I am moving from 4G to 5G, I am moving from 5G to 6G. So the step number one for us is really to explore, deliberate on the use case scenarios, and understand the pain that the current network is not able to address, and how do we really relieve this pain in a sustainable, in a cost-effective manner that all this framework, ITU framework, has already talked about. So Ashish, at this stage in time, I think our deliberation is limited to that. Of course, the next stage is to development of technology candidates, which will happen rigorously over next several years. And then by the time WRC 27 comes, that Shangju had shown the timeline, by then at least we have more or less finalized a radio interface technology that can go through the rigorous evaluation methodology that Shangjon referred to, and then we'll be ready for creating equipment, rolling out the network, and really embrace 6G. So I would encourage that if you are doing certain research in this area, please stay tuned in. If there is a specific scenario that you think is not getting addressed, please talk about. Or if there is a specific technology research area is of your interest, please get involved into TSDSI. There are plenty of opportunities for you to share your ideas and then make it a global standard. So with that, I would pause on that question. The next question, I'll quickly migrate to the next question. How to handle data accuracy while using large language model? So I would open the floor to anybody who have been working into this, the large language generative AI side, probably would like to take the question. Any of you?
Okay, I can take a stab at it. See, the question is more around the data observability, right? Like, and it typically happens around multiple steps, right? Your model is one thing, but you input the data to the model. So, your pre-processing state itself, where you see and clean the data and what you input to the model, which also guarantees your accuracy, right? So pre-processing state is very important, and that having that clean raw data is very important. So that is one stage of it. And then when you have given to the model, there definitely can be biasness, right, or hallucination of the model itself that you called, right? So what you do is basically give different sets of data to train the model so that that biasness is overcome. And also third aspect, and you do this over multiple iterations and configurations and tweaking to get that accurate result or closest result. And the third aspect will also be the feedback loop, right? Result is generated, you take that and give an input to say about the accuracy, so that model will also start evolving. So it happens at multiple stages in order to get the highest accuracy and reduce the error percentage. I hope that answers the question.
Yeah, thank you, Divya. I think we are out of time. There is one more question coming in, but I think we do not have time. So, Nishant, sorry, we cannot take your question, but the question was for Vinit in the context of mission critical application, including real-time patient monitoring, telemedicine, remote surgery. What I would request, Nishant, is get in touch with Vinit directly. Vinit, I hope you are okay. We will make your contact available, and
Sure.
then you can get in touch, right?
Okay,
But
thank you. Yeah,
more
sure.
importantly, I would encourage you to get involved into TSDSI activities. You will have ample opportunity to interact with Vinit and other like-minded people here. So since we are out of time, I'll just quickly conclude the overall session. So I would like to thank all the speakers, Mr. Shangjan, Mr. Avinash Agarwal, for giving the great overview of the 6G vision, the framework, Bharat 6G vision, and the framework. What are the exciting technologies that is going to transform our experiences in times to come, and how the next 10 years are going to look like in terms of not only evolving the standard, but actually rolling out the 6G network. In the panel, we discussed about different industry segment, how they are really going to transform their respective use case segment using the capabilities that we are expecting 6G to render. And we have a lot of exciting time ahead in terms of creating a sustainable, secure, and cost-effective technology that is for everybody. And it is completely inclusive, and it is free from any kind of discrimination. So with that, I would like to thank TSDSI, the great job by Mittalji and Shweta in coordinating this. Thank you very much. I would like to hand over to Mittalji for the last concluding vote of thanks. Thank you.
Yeah, thank you, Subhashji. We had a wonderful session where we had the privilege of listening to distinguished speakers and panelists who shared their thoughts and enriched our understanding on 6G vision and drivers. I, on behalf of TSDSI, would like to thank the co-chairs, speakers, and panelists for sparing their valuable time to be part of this session. I would like to thank all the participants, many of whom are from abroad, for joining the session and enriching the proceedings with their insightful questions. I would like to thank Shweta, the session coordinator, TSDSI IT team, Arcom team, and the AirMeet team for the hard work in organizing this session. Thank you all. And now the session is closed.